Quadratics, page 13, exercise 1DF. Find the equation of the quadratic with graph, and they have a graph here. Usually you can write whatever form of equation you want. You could write standard form, you could write factorized form, you could write vertex form. In this case, since we don't have the vertex, probably factorized form would be good because they give us the x-intercepts. So there's an x-intercept here and there's an x-intercept here. So the x-intercepts are -2 and 3. So we already know that it's going to look kind of like this, right? Because this would be the binomial that would become 0 when you put in 3, and this would be the binomial that would become 0 when you put in -2. Now the only thing we need now is the a value, and then we're done. So in this case, first we need to figure out if a is positive or negative. And since it opens down, then it would be negative. So a is negative. Negative what? Okay, so we don't really know what value goes in there yet. There's a couple ways you can do this. One is you could put it in your one of the ways you could do it is you could just put this into your GDC, and then you could guess numbers for a until you end up getting the characteristic of this parabola, which is that it's going through 12 on the y-axis. Another way you could do it is you could use algebra. So the 12 y-intercept here, that point is equivalent to 0, 12. So let's put 12 in for y, and then we'll put 0 in for x, and so that'll give us a times 0 plus 2, 0 minus 3, and I'm just gonna erase this negative for now. Let's forget the fact that we know that the number is going to turn out to be negative. So we have 12 equals a times 2 times -3, so that's 12 times 12 equals -6a. Divide both sides by -6, and we get a equals -2. Okay, so now we have everything. It's y equals -2 times x plus 2 times x minus 3. So that is the equation of this parabola. And then there's one more problem on this page that I'm going to do, 3e. So find in the form, standard form, the equation of the quadratic whose graph cuts the x-axis at 3, passes through 5, 12, and has axis of symmetry x equals 2. So let's kind of draw this first. And you know that since they gave us the requirement that we have to write in standard form, it's a little bit more tricky. So we'll write it in the form that's convenient for us, and then after that we'll use algebra to change it to standard form. So first we're going to just draw it. Cuts the x-axis at 3, so I'm going to mark 3 here. So we know that it intercepts the x-axis at 3. Passes through 5, 12. 1, 2, 3, 4, 5, and then up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I didn't draw that very well, did I? Okay. 5, 12. Axis symmetry x equals 2. So axis symmetry x equals 2 here. Okay. Cuts the x-axis at 3, passes through 5, 12. And has axis symmetry x equals 2. Okay, so the only thing we really know about it, let's see. We know a couple points, and we know the axis of symmetry. So you can tell that since the axis of symmetry is here, the vertex is going to be, I don't know, around here, right? The vertex is going to be on the axis of symmetry, and because of the way these 2 points that we have are, we can kind of figure out that it's going to look like that. So there's a couple ways we can do this. Since we have to put it in standard form anyway, let's put it use the axis of symmetry. So we'll put x equals, the axis of symmetry is at 2, so we'll put x equals 2. It's also equal to negative b over 2a. The other thing we know that is that we know some xy pairs. For example, we know that when x is 3, y is 0. And the other thing we know is that when x is, can you see how since we know it's symmetric about x equals 2, we also know that this is another x-intercept. So the other x-intercept is at 1, 0. So now let's try to put those in and see if we can figure something out. So we have y equals a 3 squared plus b times 3 plus c. And y equals a 1 squared plus b plus c. And this is going to be kind of a mess because we're going to have 3 equations with 3 unknowns, and let's try to do this a different way. So we're going to use the fact that we know the 2 x-intercepts. Okay? So since we know the 2 x-intercepts, we're going to have x minus 1 and x minus 3. We know it's going to look like that, and it's going to be multiplied times an a factor, maybe. We could have done it the other way that I gave up on. It's just that it would have been a lot more algebra. Okay, so all we need to do now is figure out a. So we just need one of these points that's not the x-intercept. We have one. It's 5, 12, right? So we'll put 5 in for x, 5 in for x, and we'll put 12 in for y, and then we'll solve for a. So 12 equals a times 4 times 2. 12 equals 8a. A equals 12 divided by 8, which is equal to 3/2. So we're halfway there. Now we have y equals 3/2 times x minus 1 times x minus 3. Now we just need to multiply everything out, which is easier than solving 3 equations with 3 unknowns. So we're going to have 3/2, and we'll have x squared minus x minus 3x minus 4x plus 3. So we have 3/2 x squared minus 12/2, which is just 6, right? Minus 6x plus 9/2. Okay, so that's it for E.